Okay, good afternoon, everyone. So this talk I will talk about the spatial pattern of COVID-19 mortality and its relationship with socioeconomic and environmental factors in England. So this research obviously is quite topical. As Scott talked about this morning, so this is account for quite a few number of presentations in this conference. And also it's one of my research areas. And it's also because I'm teaching GIS and health, so I gave students assignment to ask them to analyze COVID-19 mortality. So I did a little bit of work myself as well. I'll quickly go through a brief background and then research questions, data methods, and then present some results, and finally conclusions. So we know the COVID-19 pandemic is the single most important historical events since the Second World War. So far, the pandemic has claimed close to 3 million lives in the world, and also close to, I think it's over 130 million people have been infected. Obviously, not only the health impact, it also has a significant economic, social impact as well. So here I show a graph. This is COVID-19 mortality by the 4 countries in the UK. So we can see, obviously, the mortality due to COVID-19 of the firstly recorded first of March, and then you can see this is mortality rate by daily. This is daily number, but it's a weekly average. So you can see the mortality rate rose quickly, but obviously the rates vary greatly over 4 countries. So in the first wave, England appear has the highest mortality rate, and followed by Wales, and then Scotland, and Northern Ireland was the last. And then we have this second wave from roughly maybe October or September. And it came to the peak around late December or early January. However, we can see Wales actually has a quite high mortality rate, very similar to England, and with Northern Ireland somehow over from Scotland as third country with the third highest mortality rates. So this graph shows the mortality rate by region of England. Again, we can see obviously clear to dynamic wave. And also there was quite significant variation across regions. The first wave, London appear has very high, the highest mortality rate, and followed by Northwest. And you can see the mortality rates for London, actually it's over 3 times higher compared to the low east, that's the southwest. And when it came to the second wave, obviously it seems there is 2 or 1 minor peaks. If we see the large peak, so it is Yorkshire and Humber actually had highest mortality rate, and the London actually mortality rate has been declining over time. So there was a quite significant regional variation in terms of mortality. Obviously, this will relate to how the pandemic transmission from one place to another, and also maybe also about people's behavior and other socioeconomic factors. Because of the urgency to investigate factors relating to COVID-19 mortality across the world, there has been lots of studies, not only about the individual factors, but also on environmental, socioeconomic, geographical factors. So here I only gave you a small list of factors that has been investigated. Among them, the first of these about demographic factors: gender, age, ethnicity, household size. And in terms of gender, men appears to have higher mortality rates compared to females. And the age, obviously, we know older people tend to have higher mortality rates. In the first wave, basically, over 90% of deaths actually occur among people who are over 60. In terms of deprivation, it has been found people who came from lower socioeconomic background or live in more deprived area had higher mortality rates. And also ethnic minorities have been shown to have higher mortality rates. Underlying medical condition is another one. People with some underlying medical conditions have been also shown with higher mortality rates. Other factors, including care home, obviously we know this is a very big issue because of the lack of protective equipment and also lack of awareness in care home for the pandemic. And other physical environments like humidity or pollution has been looked at, and some research show pollution is related to mortality, but some didn't show that result. So for our research, we have 2 research questions. So first one is we look at what are spatial patterns of COVID-19 mortality and how does it change over time. And secondly, we look at what socioeconomic and environmental factors are predictive of COVID-19 mortality in England. Our research is different from previous one. For example, research has been done in England. They look at region or local authority level. And Harris research, they did use middle super output area. That's the same geography we use here. But that his research is focused in London and only focused on up to end of May. And the other difference, we also look at spatial pattern and its change over time. And the modeling strategy we use are also different. In terms of the data, we get data from ONS. So the data actually is count, so number of deaths for each middle super-Orford area from the beginning of March to end of July. So basically, it's the cover the whole period of the first wave. So the COVID-19 death is based on the death certificate. So if the COVID-19 is one of the cause of death in the on the death certificate, this case will be classified as a death involving COVID-19. Other data we used in this research, including demographic factors like age composition. So this is from the ONS mid-year population estimates in 2018, and ethnicity care home data from the 2011 census. For social deprivation, we got data from the multiple deprivation index, but we only use the income deprivation in our research. So the data is from 2019. About the viral exposure, we include the measures about the population density and also number of days since the time when there were 10 confirmed COVID-19 cases in the local authority. For the pollution data, we use the PM 2.5. That's from the DEFRA website. So this modeled annual average pollutant concentration, but we average over 5 years from 2014 to 2018. So this we assume is representative of the long-term pollution exposure. The measures we use about a spatial pattern, we use the SARS scan. That's the method developed in from 1997. So the method basically is calculate the likelihood based on observed number of deaths and compared to expected number of deaths for a particular geometry. In this case, we use a circle. So the expected number of deaths is based on the Poisson model. We use the maximum population size of 3% because we want to avoid very large hotspots in this case. For the regression analysis, we use the geographically weighted regression that's been developed from middle 1990s. So we use this method examine the association between mortality and socioeconomic environmental determinants. Obviously, this method allows us to examine whether or not the relationship vary across locations. There are conceptual justification because we assume people's knowledge attitudes that may specific to some location may be relevant to mortality rates and also people's, especially their compliance of the lockdown policies. So here is a result, but it's more or less we recap the graph we showed earlier, but this focus on monthly figure by the region. So we can see from March, April, May, June, and July, obviously the regional variation in terms of mortality rate. And at the beginning, London obviously quite at highest mortality rate, and then increase sharply to April, but at northwest and London, they are very close in terms of mortality rate. And then London obviously dropped significantly, with northwest still fairly high. The east of England also take over in May. So this again shows how the coronavirus had been transferred from one place to the other, and obviously in April, I can show obviously it's been transmission to all over the country. So here is a simple table about the summary statistics of the variables. So it shows, for example, the mortality rates. The maximum is 6,000 per million, but there are some small areas there were no mortality, no deaths at all. But this could be the figure has been suppressed by ONS because they, due to confidentiality issues, they may suppress some small numbers. So here is a map showing in March the mortality rates, so the underlying map. So the darker red color shows higher mortality rates. The circle shows the hotspot identified by the SARS-GAN program. We can see in March, most hotspots are in South East England or London areas. One particular one is Ealing Plant here, and the other is GISRUK and Dartford. And we have one near Birmingham as well, a very small one across Salford. So we can see in March, the early stage of first wave, the pandemic has been very much concentrated in London and the Southeast England and also West Midland. In April, obviously, the coronavirus has been across the whole country. You can see the COVID-19 death rate has been increased dramatically for everywhere, almost in the whole England. But at the same time, there are much more hotspots across the whole country. Especially, we can see this Chatham near Chatham, Chester, there is a large hotspot, and also Liverpool, Bolton, Sunderland as well. And it's been well known. There was a Chatham festival in, I think it's in March 2020, that may affected the COVID-19 outbreak in local areas. In May, pandemic is was starting decline. You can see the some particular northwest and some northeast hotspots still exist. Can check how much time I left?
About a minute.
Oh, sorry. Okay. I'll quickly go through this. So this is June. Again, some hotspots in northwest, northeast. In July, obviously, it's very, very few hotspots. So here I show quickly the ordinary linear square regression analysis results. We can see care home is obviously, remember, I forgot to say this is standardized variable. So you can see percentage of care home obviously is the strongest effect. And overall, the model, the R square is explain about 14%, not that good, but still useful. And we carry out of the GWR, R square improved. And if we carry out the F-test, they show there is a significant improvement over the ordinary linear square regression. And we draw the standardized residual from the GWR. It shows still clustering of the residual. So we assume there are some unexplained spatial autocorrelation here. So here it shows the coefficients, the local coefficient. So we can see the local coefficient also vary for all 7 factors. Here is a summary statistic for local coefficients. You can compare the interquartile with 2 times of standard error from the global model, and it shows there is a significant variation for local coefficients. So to conclude, our research has shown a spatial pattern of COVID-19 mortality change over the period of first wave of pandemic, and also the hotspots spreading in the peak months. A number of socioeconomic environmental variables associated with mortality, and these are consistent with previous research. But our research does show pollution, for example, is an important predictor as well. That's different from one research, for example, using the local authority in England. And our research also reviewed the mortality had a significant spatial pattern related to age, ethnic composition, and also area pollution. And again, we like to say care home, it seems the most important factor. The limitations of the data come from different time periods. We haven't included medical condition, for example, overcrowding or occupation structure. So in future, we will consider these variables and also maybe extend analysis to second wave, and also maybe do some sensitivity analysis, use count of deaths, and also transfer the reads into SMR. So thank you for listening. Maybe I'd like to answer some questions.
I've got a quick one. So do you think that the lack of good testing, particularly the early stages of the pandemic, is likely to impact on your analysis at all?
I don't think that's a big problem. That's possible in terms of, I do have one variable in terms of the infected cases, but obviously here the outcome variable is the mortality. So so I guess mortality won't be affected by testing.
Yeah, I'm just wondering whether being a COVID-associated death might have been undercounted.
Yeah, that's a very good question. Yeah, possibly. There is possible. If they don't have testing, I thought at the very beginning, this may lead to, yeah. I guess it's difficult to say how, to what extent.
Yeah, I just think you're comparing the first wave and second wave, that might be a factor.
That's right. Yeah, you are right. Yeah. So I guess, yeah. So I could do obviously separate research for second wave and then see, what are the difference and particular, see whether not there is some potential explanation, basically, about the testing. Yeah.